All around Long Island Sound are reminders that this mighty body of water is a bountiful provider of food. A lobsterman heading out off Eaton's Neck to harvest some tasty lobsters. A bayman in Huntington Bay digging clams which might be served at a barbecue. Weekend fishers casting right off the shore for striped bass, which might be cleaned and cooked that very evening. All these creatures, fish, lobsters, clams, and other organisms, depend on certain chemical components in the water, like oxygen. There is oxygen in the water just like there is oxygen in the air, and it is as vital to the life of marine organisms as it is for us on land. But around the Sound, there are so many people living, working, and playing that we affect the chemical composition of the water, sometimes for the worse. So it's important for us to know what Long Island Sound needs to be healthy and what we're doing to affect it. And that's what this program is all about, the chemistry of Long Island Sound. Our investigation into the chemical composition of Long Island Sound starts with a simple chemical component of the water, salt. Long Island Sound is comprised of salt water. One could not drink it without becoming sick because of the salt. However, the water is not as salty as water from the Atlantic Ocean on the south shore of Long Island, for example. This is because the water of Long Island Sound is a mixture of salt water from the ocean, which comes in through both the eastern and the western end of the Sound, and fresh water from rivers. Most of these rivers are on the Connecticut side of the Sound, the largest being the Connecticut River. In fact, 96% of the fresh water entering the Sound does so from the Connecticut side. The amount of salt in the water is its salinity. The waters of the Sound have a different salinity in different places at different times of the year. For example, the salinity is higher in the eastern Sound, close to the greatest influx of ocean water, than it is in the western Sound. The salinity also tends to be lower throughout the Sound in the spring.
This afternoon, considerable cloudiness and mild with a 40% chance of a shower or thunderstorm.
At this time, the rain is heavier and the snows of winter melt up north and empty into the Connecticut River. The inflow of fresh water is 20 times greater during the spring than in late summer. Salinity also tends to be greater in the lower layers of the water column than in the upper layers. This is because fresh water has a lower density or is lighter than salt water at an equal temperature. Therefore, it tends to float on top of the higher density or heavier salt water. Let's continue our exploration into the chemical makeup of the Sound with a look at the tiny one-celled marine plants called phytoplankton. Though an individual phytoplankton cannot be seen without the aid of a microscope, these tiny plants are so numerous that they are a large source of oxygen in the water. This is because of the biochemical process called photosynthesis. During this process, plants, such as phytoplankton, convert carbon dioxide to organic carbon with the aid of sunlight and nutrients. Oxygen is a byproduct of the process. Because sunlight is at the surface, phytoplankton tend to accumulate there. But in order for marine plants to produce oxygen through photosynthesis, they need nutrients, food. This food comes to them through other chemical components in the water, such as nitrogen and phosphorus. Nitrogen and phosphorus are also two common elements in the fertilizer that we put on our lawns. The same nutrients which feed the grass on our lawns also feeds the marine plants in Long Island Sound. We'll learn more about nitrogen and phosphorus a little later in the program. The chemical process of photosynthesis carried out by phytoplankton and other marine plants is only one source of oxygen to Long Island Sound. The primary source of oxygen actually comes from the atmosphere, the air. This oxygen is transferred to the surface waters through the action of the waves. Oxygen is consumed by organisms throughout the water column, such as fish, which filter oxygen out of the water by passing water through their gills. On the bottom, there are more oxygen consumers, such as lobsters, horseshoe crabs, and many other smaller organisms, such as bacteria and zooplankton. Whereas phytoplankton are tiny plants, zooplankton are small animals, such as these copepods. All these oxygen consumers use oxygen to decompose food. Decomposition, whether on land or in the sea, is like a little fire that burns away matter. Like all fires, decomposition requires oxygen to keep burning. When something dies in the Sound, the decomposition of its organic matter releases some of its chemical components into the water. These include the two chemical compounds we mentioned earlier, nitrogen and phosphorus. But the decomposition of matter in the water column is only one source of nitrogen and phosphorus to Long Island Sound. Much larger sources of nutrients are from the air and from the land. When it rains, much of the water in Connecticut and Long Island seeps into the ground. Some of it is collected in lakes, ponds, and small puddles, or gets evaporated. But tremendous volumes of this rainwater drains off the land into rivers or into storm drains in the street. All of this water eventually ends up in the harbors and bays of Long Island Sound. As it drains into the Sound, rainwater collects decaying matter. This decaying matter decomposes in the Sound and releases nutrients. This is one of the major sources of nitrogen to the Sound. Another source of nitrogen is sewage treatment plants. There are 44 sewage treatment plants which discharge just under 1 billion gallons of treated sewage every day into Long Island Sound. Did you ever wonder where it all goes when we flush the toilet? For many homes on Long Island and in Connecticut, this sewage goes into a hole in the ground, a cesspool or septic tank. This is a very large cesspool being constructed for a retirement home. The water seeps out of the cesspool into the ground, and the remaining organic matter is decomposed by bacteria. But in many coastal communities around the Sound, when a toilet is flushed, the sewage goes into a pipe and is directed toward a sewage treatment plant. This is one such plant on the Sound in Glen Cove, Long Island. Although the facility itself looks complicated, the process of treating sewage is easy to understand. The sewage is first passed through screens to remove the large debris. Then the sewage that passes through the screens is sent to these large circular tanks, where the solids drift down to the bottom to be collected and treated again. The water is then sent to these secondary tanks. Here the water is aerated with bubblers on the bottom. This churning action forces oxygen into the water, much like the process wherein oxygen is transferred from the atmosphere to Long Island Sound through wave action. This aeration process aids in the decomposition of organic matter. After a time and much testing, the sewage effluent is discharged into the bays, harbors, and rivers of Long Island Sound. By this time, the organic matter in the sewage has been almost completely broken down to its component elements, primarily various forms of nitrogen, such as ammonia, nitrate, and nitrite. Pouring all these nutrients into Long Island Sound feeds the marine plants in the water, particularly phytoplankton. It's just like pouring fertilizer into the water. Now, although this is good news for the health of phytoplankton, it can spell trouble for Long Island Sound. And the trouble usually begins in the springtime. In spring, there is a longer period of sunlight with each passing day. This increased sunlight promotes an explosive growth of phytoplankton, the one-celled marine plants. The waters of Long Island Sound experience what is called a phytoplankton bloom. Though these are tiny plants, during a phytoplankton bloom, the waters can actually turn green or brown with their numbers. The fuel that fires this overgrowth of phytoplankton is nitrogen. Nitrogen enters Long Island Sound from sewage treatment plants and from the water which runs off the land during the spring rain. Later in the year, the summer sun starts to heat up the surface waters. The difference in temperature between the upper and lower layers of water increases. A sharp distinction forms in the water column between the warmer, fresher water on top and the colder, saltier water on the bottom. In the summertime, there is usually mild weather as well, without the storms that come in the spring and the fall. So with wind and water calmer, there is no force strong enough to mix these two layers. Because of this barrier between the two layers of water, the oxygen produced in the top layer by phytoplankton and added from the atmosphere does not get circulated to the bottom. As the phytoplankton bloom dies off, large quantities of these tiny plants sink to the lower layers of water. Here, the dead phytoplankton are decomposed by bacteria. As we learned earlier, the process of decomposition requires the consumption of oxygen. This triggers the onset of hypoxia, or a shortage of oxygen in the water. In Long Island Sound, hypoxia normally occurs in late summer and is concentrated in the Western Sound. The decomposition of all this dead plant material by bacteria consumes the oxygen in the bottom layer of water that is needed by other forms of life. Life that can migrate out of the area, such as finfish, usually does. Life that cannot move, such as clams and lobsters in traps, may die. As the dead animals are decomposed, more oxygen is taken from the lower layer once again, further depleting the bottom waters of oxygen. At times, it has gotten so bad that there was no oxygen at all recorded in the bottom waters of western Long Island Sound. The waters are then classified as anoxic, completely devoid of oxygen. Aboard the Onrust, the research vessel of the Marine Sciences Research Center at the University at Stony Brook, student scientists are recording the levels of oxygen at various depths of Long Island Sound. This device, a water sampler, is lowered over the side.
It's going to go out. Make sure hang on to it. Check it down with it. Check it out. You want to just make sure that it doesn't hit the boat.
An electronic signal triggers the opening of one of the sample bottles, which quickly fills with water from that level. The device is lowered again, and more samples are taken.
Gantry helps a lot.
Watch your fingers when it sits down. You never want to hold on to the bottom in case you're
Back on deck, the samples are emptied and analyzed.
or plants or anything.
Samples of this water will be tested back at the lab.
Yeah, I don't know what that is. Probably just like a lot of times you get seeds.
Hypoxia is a natural process that has been aggravated by the human population in this region, which discharges so much nitrogen into the waters of Long Island Sound. The western Long Island Sound is particularly vulnerable to hypoxia for several reasons. Nutrient levels are usually highest near land, where the major sources of nutrients are located. All of the western Sound is close to land sources of nitrogen. Also, the population is greater in the areas surrounding the western Sound, including the boroughs of New York City, the Bronx, and Queens. More people means more partially treated sewage being discharged. In addition, the bottle-like shape of the Sound restricts the circulation of the water and the wind in the western Sound, which is the narrowest segment of the estuary. Lastly, the estuarine circulation concentrates oxygen-consuming materials in the western Sound. Scientists have suggested that nitrogen is the limiting nutrient for phytoplankton in the Sound. This means that the advent of these extraordinary blooms of phytoplankton can be controlled if we can control the amount of nitrogen that enters Long Island Sound. One of the primary recommendations of the Long Island Sound study, completed in 1993, is to prevent an increase in nitrogen input into the Sound. For example, if a new housing development is built, the sewer lines for these houses may need to be connected to the existing sewage system to dispose of its sewage waste. This would, of course, send more waste to the sewage treatment plant. More waste in equals more nitrogen out. Because of the new regulation, additional controls would have to be implemented to keep the nitrogen output at current levels. Preventing an increase in nitrogen input is considered an important first step to actually lowering the amount of nutrients that are put into Long Island Sound. Excessive nutrients in the Sound are only one of the troublesome contaminants that exist here. There are two other classes of pollutants of concern: heavy metals and organic contaminants.
Hold it, Brett.
By taking sample cores of the bottom sediments, scientists can virtually look back in time at the health and history of Long Island Sound.
But it also could be that we have
Geologists know, for example, that it takes about 25 years to add another inch to the muddy bottom in western Long Island Sound. So, by taking a core sample that is 10 inches deep, they are examining a cross-section of the sediment history of Long Island Sound that goes back some 250 years. These core samples reveal that with the coming of the Industrial Revolution in the early 1800s, more and more heavy metals appear in the sediment. These heavy metals include lead, copper, chromium, mercury, zinc, and cadmium. The increase of heavy metal in the Sound is not surprising, considering that with the coming of heavy industry, these metals are used more and more in the fabrication of everything from household plumbing to gasoline to paint. Heavy metals at high concentrations have been shown to decrease the survival rates of young fish, as well as cause abnormalities such as liver tumors in adult fish. Heavy metal contaminants tend to build up in marine organisms and may be a health hazard to the people who eat them. The most recent studies show that a large portion of the heavy metals entering the Sound do so through the atmosphere and through rain runoff. Historically, emissions from car tailpipes are the single greatest source of lead to the Sound. The levels of lead from automobiles has been drastically reduced in recent years, however, because of the mandating of lead-free gasoline as fuel. The concentrations of other heavy metals in Long Island Sound have been decreasing in the last decade as well. This is due partly to the fact that much of the heavy industry that discharged into the rivers and harbors of Connecticut have left the area. Government regulations have also decreased the input of heavy metals into the Sound. Pre-treatment programs are required of many industries which are potential polluters. Lead-based paints have been banned. Toxic bottom paints for boats have also been banned. When compared with the EPA guidelines for heavy metal contaminants, the concentrations of heavy metals found in fish and shellfish from the Sound indicate that the Sound is relatively healthy. The third class of pollutants of concern are the organic contaminants. These are contaminants that contain carbon atoms. Organic contaminants include polynuclear aromatic hydrocarbons, known as PAHs, DDT, and polychlorinated biphenyls, known as PCBs. DDT is a pesticide that was used extensively prior to being banned in the early 1970s. PCBs, also now banned, have been used primarily in the manufacture of electrical insulators and were discharged directly into the water by the manufacturer of these products. Although both DDT and PCBs have been banned from use in the United States, The compounds are resistant to breakdown and persist in the marine environment for long periods of time. PAHs are formed during the combustion of fuels of all kinds: oil, gasoline, wood, and coal. One of the major sources to Long Island Sound for these organic contaminants is also the atmosphere and rain runoff. Concentrations of these compounds also tend to increase from east to west. There are numerous adverse health effects from high concentrations of organic contaminants, including, in some cases, cancer. There are health advisories to protect the public from a harmful level of exposure to these contaminants. And with few exceptions, marine organisms in Long Island Sound carry concentrations of these chemicals that are within government-approved levels. Very few shellfish have been found that have DDT, PAH, or PCB concentrations that are toxic to humans. However, striped bass and eel have been found to contain concentrations of these contaminants that approach or exceed the government-approved limits. Now we know a little about the chemistry of Long Island Sound. We learned about the importance of oxygen to marine organisms and where oxygen comes from. We also learned how oxygen can be depleted through the phenomenon known as hypoxia. We learned what role nitrogen plays in the growth of marine plants and the advent of hypoxia. We learned how sewage treatment plants contribute nitrogen to the sound. We learned about two other classes of pollutants: heavy metals and organic contaminants. We learned where they come from and what they can do to marine life in the Sound. We've also learned that Long Island Sound is still a relatively healthy body of water, a place where lobsters, clams, and fish can be caught and eaten. And that in many respects, the Sound may be getting healthier over time. But we've also learned that there are threats to its chemical makeup. And now that we know a little more about the waters of Long Island Sound, we too can fight to protect its health.